All right, welcome back. So today I'm going to review some differentiation rules, and differentiation is the same as taking the derivative. They're two different words. Let me just write that down. Differentiate is the same as take the derivative. And suppose we were asked to find the derivative of the following: x cubed plus 4 sine of x minus 5 cosine of x plus 3 to the x plus 4 times e to the x. Well, I guess we know one of the terms. I guess we would know that the derivative of x cubed is going to be 3x squared, but we haven't really seen how to do anything else. So we haven't learned about the derivatives of trig functions yet, and e to the x and 3 to the x, they do kind of look similar to like x cubed, but notice that x cubed is really different from 3 to the x, right? So they're really, really different functions. For instance, if we were to do, if we were to plug in x equals 10, that's over here we're going to get 10 cubed, that's 1,000. And over here we would get 3 to the 10th, which is 3 times 3 times 3. We multiply 3 by itself 10 times. So those are really different numbers, and as such the derivative of 3 to the x is going to be different than the derivative of x cubed. So in class we'll sort of talk about where these derivative formulas come from. I might make another video about that as well, but for now let's just sort of see the rules. So we're going to basically do 4 rules on this slide, and these are rules that are pretty easy to remember. The first is that the derivative of sine of x is cosine x, so notice this little apostrophe there means take the derivative. So this says the derivative of sine of x is cosine. The derivative of cosine x is minus sine. If we go forward one slide, the next rule says that the derivative of e to the x is itself. So that sort of means e to the x is its own derivative. That's really cool. It's the only, basically the only function in the whole universe that's equal to its own derivative. That's really cool. That'll come up later, and if you take differential equations or you want to study rates of change. So that's really great. And then the last ones we're going to look at are how to take the derivative of a number to a power. So here I've done an example. So what's the derivative of 3 to the x? Well, just like with e to the x, the derivative is kind of itself. But then we have to multiply by this correction factor, right? So the derivative of 3 to the x is going to be itself times the natural log of 3. And as you might expect, the derivative of a to the x is going to be the same rule. We get 3 to the x, we get a to the x, then we multiply by the natural log of a. So there's another video about properties of natural logs, if you want to go back and look at that to review some log properties. And the one thing I want to point out is this a separate rule? Let's see, what would this rule say? The derivative of a to the x, so a is some number, says that the derivative is a to the x times the natural log. Well, what if we plugged in, what if we plugged in 9? So if we take the derivative of 9 to the x, this should be 9 to the x times the natural log of 9. That's correct. But what if we were to plug in e? Well, we just use the rule. The derivative of e to the x should be e to the x times the natural log of e. And wait a minute. Up here, didn't we say that the derivative of e to the x was just e to the x? Well, what's going on? Well, what's going on here is that the natural log e, this is just equal to 1. Right? So this formula for the derivative of e to the x is just a special case of the general formula down here. So let's just close by doing a few examples. So let's find the derivative of 10 to the x. That's going to be 10 to the x times the natural log of 10. And let's go back to our original problem. Well, We already did the first term. The derivative of x cubed is 3x squared. Let's see. Well, I see I have a constant 4 times sine of x, so the derivative is going to be 4 times the derivative of sine of x, so that's 4 times cosine of x. And then, same thing here, we have a minus 5 times cosine, so our answer is going to be minus 5 times the derivative of cosine. And what was that? Well, let's remind ourselves the derivative of cosine is minus sine, so we're going to put minus sine in here. And then finally we go to the next term is going to be what's the derivative of 3 to the x? That's 3 to the x times natural log of 3. And then finally we have 4 times e to the x. And that's going to be, the derivative is going to be 4 times the derivative of e to the x, which is just e to the x. Okay. So this sort of shows all of those rules put together. Let me close with just one, maybe slightly different problem. So let's cross this off. Suppose our function was f of x equals, I don't know, let's do something 4e all to the x power. Okay? So how could we find the derivative of this function? Well, remember, this is equal to something to the x power. It's equal to some number a. Well, what is that number? Well, that number is just 4 times e. So a is, probably roughly 11 or something like that, whatever 4 times 2.7 is going to be. And so if we want to find our derivative, well, our derivative is going to be still that a to the x times the natural log of a. This is where I like to think of this a as being a placeholder for what's inside. And so now if I just go back and I replace that, it's going to be 4e to the x times the natural log of 4e. And that's going to be our answer. So thanks for watching. Stay tuned for more videos, and comment, email with any questions. Thanks.